onto this new diagram. And then let's say income in this budget constraint was, in the first budget constraint was, let's say 100. So that's M equals 100. This is M equals 200.
Mm-hmm.
Then, yeah, we just take these 2 points on the y-axis, draw those lines across, and then we find the first coordinate, which was M equals 100, and this x, so that'll be bottom corner, and find this one, which is top corner, and then we'll just connect the two together, like that, and that's our angle curve.
So it's not really a curve; it's more of a straight line.
Yes, it depends on how you draw it. Really, you could have it as a curve, or I've just done it as a linear function here.
Okay.
So, given that demand for X1 increases as income increases, would you say that's the normal good, or inferior good, or what type of good do you think it is?
A normal good.
Mm-hmm. Yeah. So, when the angle curve is positive, and there's a positive function, then it's a normal good. Cool. So that's the income offer and angle curves. For the price offer, yep, sorry.
In words, so obviously graphically it's quite clear. In words, how would you define the income offer, or like?
So the income offer connects the optimization points related to changes in income rather than changes in price.
Mm-hmm. And then graphically, it's just literally a straight line through the different tangency points of different budget lines where money incomes change.
Yeah. So it doesn't necessarily have to be a straight line. So you could have maybe these coordinates here, and therefore you'd find that it'd be kind of quadratic in nature. But just for simplicity, I've drawn it as a straight line, but it could be curved.
And likewise, with the angle curve, it could be a loop.
Yeah, exactly. It could take any shape. It could be decreasing, it could be increasing, it could be quadratic, it could be linear. We don't know. It depends on the type of good it is.
Okay, sure.
So I'm going to do some very similar analysis, but now I'm going to find the price offer instead of the income offer. And instead of the angle curve, I'm going to plot the demand curve. So we'll have X1 on the horizontal axis. We'll have X2 on the top diagram. Okay, so now instead of income changing, what's going to change is the price of X. So let's say the price of X decreases, and therefore the budget constraint kind of pivots outwards like this. Then we'd move to a new optimization point from A to B and on a higher indifference curve.
Yeah.
So now we've got this new optimization points with this amount of X1 being demanded. So let's call this like that. And then for the price offer, we just connect the two optimization points to each other like we did with the income offer. But now instead of calling it the income offer, we call it the price offer. And you can also extend this like that if you wanted to.
Yeah.
Cool. So the price offer shows the movement from different from one optimization point to another based on changes in the prices of the good.
Mm-hmm.
And then, yeah, as we did with the Engel curve, we'll just take these new coordinates for x1 downwards, and we'll say with the old budget constraint, the price of x1 was, let's say the price of x1 was 2. In the new budget constraint, price of x1, say that's 4. So now we have 2 and 4 on here. So take those across. Right, that should be the other way around.
Yeah.
Yeah, so we have 4 and x11 here, 2 and x12 here. We just connect these together, and this will be the demand curve. We have price of x1 on the vertical axis, on the y-axis, and the demand for x1 on the horizontal. So this is just a demand curve. Cool, so this obeys the law of demand, which states that there'll be a negative relationship between the price of a good and the demand of the good. There are examples of goods that don't obey this law of demand.
Yeah.
You'll see that in the case of Giffen goods.
Yeah.